All right, this is section 13.1, chemical reactions and equation. And here's the objectives. Be able to explain what happens during a chemical reaction, be able to identify reactants and products, convert verbal descriptions of chemical reactions into chemical equations, so we'll learn how to do that, and then use these symbols appropriately. All right, so first of all, if we're talking about a chemical reaction, we're talking about a process where we've got one or more substances and they're changed into new ones. You know, it could be one or more of those when we get done. And the substances that are there at the beginning, so the starting substances, we call those the reactants. And the ones that are at the end, or what we end up with, the finished product, is known as the products. Those are the products. So we have reactants at the beginning, products at the end. Okay, so let's say that let's look at this example. It says when sulfur dioxide is added to oxygen, sulfur trioxide is produced. So the things that we started with sulfur dioxide, we added oxygen. These are the reactants. And what the final product was, and notice that we had two things when we started, but we only get one at the end. This is the product. Okay, so we have reactants, we have products. When we write symbols, or when we write these equations, there are a lot of symbols that we are going to use. One really common one is an arrow, and that usually separates the reactants and the products. It means yields or produces. You know, in between products or in between reactants, we would use a plus sign. That separates the different things. So we would say, like over here, they've got silver nitrate and sodium chloride, and we put the plus sign in between to indicate that they have two different things. And then we have the state symbols. These are the state symbols. We have solid, liquid, and gas for the different states that things might be in. And then one that maybe you're not very familiar with, AQ. And this is a really common one in chemistry. AQ stands for aqueous, and what it means is it's dissolved in water. So if you took some salt and you stirred it up in water, it would dissolve, and then it would become aqueous. And it's important that we indicate this because salt, as a solid, would not do certain things that salt dissolved in water will do. And so it's important that we talk about whether things are dissolved in water or not. We have different options, a way we could describe this. We could describe it with pictures like we have up here. So, you know, we could be talking about hydrogen plus oxygen yields water, and we could draw pictures to describe that. Or we could use words. We could say 2 molecules of hydrogen gas react with 1 molecule of oxygen gas and produce 2 molecules of water vapor. Or our third option, and probably the one that is the easiest to write, would be to write a chemical equation, a shorthand equation like that. And that's why we're talking about these equations now. Easier way to kind of take care of this, to explain this. All right, so let's take a look at an example. It says an aqueous solution of calcium nitrate is added to an aqueous solution of sodium hydroxide to produce, this should be produce, solid calcium hydroxide and an aqueous solution of sodium nitrate. So we could write that all out like that in words, or we could write it out in symbols. Okay, so this says exactly what I just read to you up above. Much simpler to write that equation. It's got all the stuff. We're talking about calcium nitrate. We're talking about aqueous solutions and so on. So you can see that's the same thing. And by the way, note that I did mess up and I didn't use those and make those as little subscripts, which they should be. So don't think that we did something different here. I just didn't turn them into subscripts there. All right. I want you to take a look at these following things and see if you can I want you to write this first one as a verbal description, and numbers 2 and 3, I want you to write those as word or as symbols. So stop the video and take a look at that and do that right now. All right, so here's our solutions here. So for the first one, we could say an aqueous solution of hydrochloric acid reacts with an aqueous solution of sodium hydroxide to produce an aqueous solution of sodium chloride and liquid water. And on the other ones, you can see we've got C3H8 gas plus O2 gas yields CO2 and H2O liquid. And the last one, the hydrogen fluoride gas, HF, K2CO3 aqueous, yields KF aqueous plus H2O liquid plus CO2 gas. Now notice that it is important now that you still be able to write these things. So, we have to be able to say, can we take hydrogen fluoride and turn it back into symbols? Can we take potassium carbonate, turn it back into symbols? And remember, potassium carbonate, you would have to figure out what those things were. And then, possibly do the crisscross method to write that. You still will have to do this. You'll have to be able to put those together to write a formula, and then later we're going to talk about how to balance those equations. So you've got to go back and pull all this stuff that we've done before, which is why it's so important to learn it when we were going over it at the beginning. All right, so that's the end of this. The end.